So let's continue. Question 11. This is 2021 SBP Physics paper 1. Okay. So diagram 6 shows a sealed syringe containing air trap is heated in a beaker filled with water. After heating, the position of the pistons moves outward. Okay, so the piston moves upward. Okay, so this is the concept you need to know regarding the gas law. So we have three gas law. The first one is, okay, so let me show you PVTM. Okay, so this is mass. So for your syllabus, your mass is always kept constant. So P refers to pressure, V is the volume, T is the temperature. Remember, your temperature is in unit Kelvin. Okay, so let me show you how to remember. We have three gas law. One is Boyle's law. The second, Charles law. And the third one, Gay-Lussac's law. Okay. So PV is Boyle's law. VT is Charles' law, while PT is your Gay-Lussac's law. So the first one, Boyle's law, states that, PV equals to PV. The Charles' law, VT is VT, V over T equals to V over T. And your Gay-Lussac's law is PT, okay? So is P over T equals to P over T, okay? This is P. Okay. So for this question, when you hit it, your kinetic energy increase. You apply more heat, so the kinetic energy of your particle increase. So your pressure also increase. Okay, so let's see. The heat supply to the water causes the temperature and mass of trapped air increases. So this is not true because, as I said just now, your mass should always be constant. Okay. The pressure of trapped air increases due to the increase in temperature of the trapped air when heated. This is true because the temperature increase, the kinetic energy of the particle increase, so the particle collide more frequently with the wall of the syringe, so the pressure increase. As the temperature increases, the volume of trapped air increases, but the pressure of trapped air is constant. No, the pressure is not constant. The pressure should be increasing. The volume of trapped air increases and the pressure of trapped air decreases. Pressure decreases, no. When your temperature increases, your pressure should also be increasing. So the answer is Boyle. Okay. So next, which physical quantity decreases when a vibrating system experiences damping? So damping. So let's say this is your spring, okay, and this is your object. You oscillate it. So when you plot the graph, you'll find that this is the displacements. All right. Okay, this is your time. So you will get a graph like this. So you can see here, okay, the amplitude is decreasing. Okay, the amplitude here is decreasing because the energy is decreasing because you have air resistance. Okay, so when the air resistance will resist resist the movement of this object, so your amplitude should be decreasing. So because of the energy decreasing, your amplitude decreasing, but the frequency is not decreasing. So the distance here and the time here is the time for this both sides is same. Okay, the time will always be the same. So the only changing is the amplitude because your energy is decreasing, so your amplitude is also decreasing. And so this is no frequency is same, velocity is same, the wavelength is also the same. Diagram 7 shows plane wavefronts propagate towards a plane reflector in an experiment by using a ripple tank. Okay, sorry, ripple tank. Yep, ripple tank. Which pair is correct to describe the reflected wave? So remember, reflection, this is the reflection of wave, is always the same except for the direction. The only change is the direction, alright? So the wavelength here is the same, and because the wavelength is the same, the frequency should also be the same. Remember? Okay, V equals to F lambda. So your velocity is same, your wavelength is same, so your frequency should also be the same. Okay, so frequency of wave is same, wavelength same. The answer you get is dot key. Okay, the only change is your direction. So remember, this is your normal line. The angle of incidence is also equal to the angle of reflection. Okay, because this is reflection. Okay. Alright. Diagram X shows two campsites that are separated by a lake. At dawn, the sound from the opposite campsite can be heard clearly. So this question is, which phenomenon explains the situation above? So it's refraction of wave. So let me explain to you. So because of our lake, our water have a high specific heat capacity. So at dawn, our lake will be warmer, and the upper layer of air is colder. Okay, so when your sound propagate from warmer area to colder area, it will diffract upward. Okay, sorry, I didn't draw it nicely. Let me draw again. So it will be diffract upward. Okay. So because it is diffracted upward, so you can see more clearer at the opposite campsite. So the answer should be boy, because this involves the refraction of wave, where the sound wave travels from a warmer to a colder area. Remember, the colder is denser and the warmer is less dense, so it's just refracted. Okay. Next, diagram 9 shows water waves propagating towards a gap. Okay, so this is diffraction. So the water will appear like this, the water pattern, after passing through the gap here. So what is a wave phenomenon and the shape of wavefronts after passing through the gap? So you know this, after passing through a gap, this is called diffraction. So this is wrong. And when passing from a gap, it is always circular. The shape of the wavefront should always be circular. So your answer is A. Okay, so we do not have we rarely see the plane of the wave. The shape of wavefront is plane. Okay, the only shape we have is when passing is circular, or when you see when it gives you a shape like this. Okay, this is the object and your water wave, and it's diffract, so it will appear like this. Okay, because it's diffract. Okay, so you won't gain a plane shape of wavefront actually. Diagram 10 shows the apparatus arrangement for the experiment to produce an interference pattern on the screen using red light. Okay, so when you see this type of question, you need to know a formula where lambda equals to ax over d, where distance is from the screen to your double slits, your distance. Lambda is your wavelength. A is the okay, let's enlarge these double slits. It should be, this is the double slits, and then you have two holes here, and your laser pen is at here. When your laser pen, the light from the laser pen pass through these two holes, it will form a pattern like this. You have dark fringe and bright fringe. You will get dark fringe and bright fringe. Okay, so the distance here is A, and the distance between two black fringe is your x. Alright, so this is your formula. Lambda equals to ax over d. What could be done to increase the distance between two consecutive dark fringe? Okay, so you want to increase the distance between two consecutive dark fringe, which means you want to increase your x. So you want to increase your x, your d, okay, when you move the x here, lambda x equals to a d. Oh, sorry. Wait. Lambda d equals to ax. Okay. So you can see here d is directly proportional to x. So d increase, x increase. So use a bigger screen. No, this equation have nothing to do with the size of screen. Increase the distance between the screen and the double slit. Yes, because you see here the distance increase, your x increase because d is directly proportional to x. Yes, this is correct. Replace the red light with a green light. So your red light have a longer wavelength with your green light. So when your wavelength decrease, your x should also be decreasing. So this is not true. Use a double slit with the larger distance of separation. So okay, you move a here, you get lambda over a equals to xd. So you can see that x is inversely proportional to your a. So when your a increase, your x should be decreased. So this is also a no. So the answer should be boy. Okay, diagram 1.1 shows a light ray directed normally to a PQ glass prism. So here you will have 90 degree, given that the refractive index of the prism is 1.5. So you need to find the critical angle of this prism. So remember your formula, n equals to 1 over sine c, your critical angle, where your n is 1.5, sine c equals to 1 over sine c, and c you get is 1 over 1.5 sine is 41.8. 41.8. So, okay. So, when the incident angle is larger than 41.8, you will get a total internal reflection. Okay, so this is a 90 degree. So here is 90 degree. So here you should also be 90 degree. So 100 minus 70 degree minus 90 degree, you will get 20 degree. Okay, so remember our incident angle is always between the incident ray and the normal. Incident ray and normal, okay, so you need to find the angle here. 90 minus 20, you will get 70 degree. So at here, the 70 degree is larger than 41.8, so you will get a total internal reflection. So remember the condition for total internal reflection is that first one, you have the light is travel from a optical denser region to a optically less dense region. So denser to less dense, that's right, from denser to less dense. So is it correct? And the second is we have to be the incident angle of the incident ray should be larger than the critical angle. So this diagram fulfill the two conditions of the for the total internal reflection to occur. So the answer should be donkey. Diagram 12 shows an incomplete ray diagram of for concave lens. Determine the position of the image. So our image always occur when at the point of intersection of the two light ray. So remember our concave lens, the image we get is SUV, which is smaller, upright, and virtual. So virtual, when the image is virtual, which means that the light ray does not intersect. So we just draw a dotted line here. So you can see the light, the image is formed about here. Because this is the same side, the image form is same side as the object. So this is a virtual image, and also the light ray does not intersect. Okay, we just draw this line for it to intersect, but actually the light ray is not intersecting. So this is how the virtual image form. So the answer should be B. Is approximately at the position B here. Okay. So convex lens, you will always get an image smaller, upright, and virtual. This is for concave lens. Okay, concave lens, you will get SUV. But if the questions asks about this convex lens. Okay, so let me show you how to memorize it. Okay, so this is your convex lens. All right. Okay, you have. This is F, and 2F here, and also 2F here. Okay, so when your object is located further from 2F, you will get a small image at between F and 2F on the other side. Okay, so you can see the image is smaller than the object. When your object is located at 2F, and you will get object of the same size at 2F. Okay, so the object at 2F is equal in size with the image at 2F. When your object is located between 2F and F, okay, you will get an image further from 2F and larger in size. So you can see that when your object is getting closer and closer to your optical center, your image is getting larger. And remember, at 2F, your image and object is in equal size. Okay. When your object is at your focal point, then your object will form at infinity. It will form at infinity. And when your object is formed between F and your optical center, you will get a larger image at you will get a virtual image which is located at the same side as the object, and it is further from your F. Okay, so you can see when your object is getting closer, your image is getting larger, and when your object is located between optical center and your F and your focal points, your image is virtual and larger. Okay, so this is how you memorize it. So let me introduce you a formula. You see SIR. Okay, this is case 1. So this is case 2. Oh, sorry. Okay, so this is case 1, SIR, when your object is further from your 2F. And case 2, when your object is located at 2F, MIR. Between 2F and F, you will get similar, you will get LIR, LIR. Between 2F and F, and at F, you'll get LUV. And between F and the optical center, you will have also LUV. So this is how you memorize it. You have 5 cases here. 5, 4, 3, 2, 1. Okay, SIR means smaller inverted real. M represents same size inverted real, larger inverted real, larger upright virtual, larger upright virtual. So when the question you saw the object is located further from 2F, so you will have SIR, smaller inverted real. This is your image. And located at 2F, you will have same size inverted real image. So remember, virtual always come with upright. So virtual and upright, they are always in pair, and real and inverted, they always in pair. You will never, for your syllabus, only for your syllabus, you will never get inverted and virtual image. Okay, you will get inverted and real, they will always exist in pair. Alright. So next, okay, this question is a little tricky. Diagram 13 shows an image of a leaf observed by using a magnifying glass. So which combination for the situation above? So this magnifying glass, we know that you want to magnify it, so your image definitely will be larger, and also you will get an upright image, alright, not an inverted image. You don't want to get inverted image, so you have upright image. And as I mentioned just now, upright will always come with virtual. So this is what you want to get. So we look up here, love. This is V. Okay. So in order to get this love, L-U-A-V, we will choose case 2 or case 1. But we will not choose case 2 because case 2, remember, our image will form at infinity. Alright. So if the image is formed in infinity, which means you can't get it, you cannot see it. And usually infinity, image that is formed at infinity, we apply it on a telescope. You will need the image formed at infinity. So at here, we will choose case 1. Okay, case 1, LUV. Okay, so for case 1, we know that your object will located less than, your object will located between focal points and your optical center. Okay, let's see. So the answer should be A, because the focal length of magnifying glass is 15, and your object distance between the leaf, between your object and your glass, is less than 15. So you will get LUV here. Okay. So finally, the last question we discussed today is diagram 14 shows a concave mirror is used to examine a patient's teeth. So this is a mirror. So remember, our concave mirror will have the same characteristic as convex lens. Okay, whereas our convex mirror should have the same characteristic as concave lens. Okay, they are opposite. Concave mirror, same characteristic, and convex lens. Convex mirror have the same characteristic as concave lens. So what image characteristic are correct for the concave mirror? So concave mirror will have the same characteristic as convex lens. So you want to so definitely for the dentist, to ease the dentist, the glass will magnify the image, so you will get larger image, and definitely you want an upright, not an inverted, and upright always come with virtual image, so large, upright, virtual. So this is diminished means smaller, so this is definitely wrong. Virtual always come with upright, so this is also wrong. So virtual, upright, magnified. So we have the answer donkey.